You want me to stand on a desk and sing to me?
Yeah.
Too bad.
Oh, come on.
Midpoint sums are rectangle based, okay? And I kind of gave you this a little bit earlier, but the rectangle height is based on what's in the middle, okay, of your intervals, right? So the biggest way that we actually see this is in a table form. So it would say something like, given, and it would be given an actual table. So you're given a table with values in it. I'll just make it easy.
Does it give you?
Yeah, it does. And it might say something like estimate. Good job. Okay, so we want to estimate.
Will the table of values be given to you if it's asking for this one?
Maybe. Like I said, most of the time, midpoint sums come straight from a table. But can you generate a table?
Yeah, you're doing a function.
You can. Okay. Okay, so we are going to estimate the integral from 0 to 13. So note 0 to 13. There have been problems that I have presented to people that would say, give this table, but only 0 to 9. So be aware of the x values there. Of the function v of t with a midpoint sum of 3 subintervals.
Could that just be M23?
Yeah, so you could also
Only 3 subintervals?
you could also say calculate M3. This is more of a book-based question. Okay. This is definitely how they're going to ask you, or something very similar to it. All right. So how do I get 3 subintervals out of that table? So what are my, yeah, it's divided into 3 parts, right? So, so if this is rectangular based, my first rectangle is how wide?
5.
6 units. It is 6 units wide. Okay. How tall is it based on the middle number?
2.
There's your height. The midpoint. Right. It tells you midpoint, so pick the middle. So 6 times 2. So your rectangle is 6 wide, 2 tall. Okay? Kellen,
This only works if you have like an average. So, okay, if you look
Pretty
at the
much.
midpoint when it comes to graph, how would it look as far as like drawing?
I'll show you one.
Wouldn't it be free?
Okay. Next one, how wide is that rectangle? 3 units, because 6 to 9 is 3 units. And
4.
middle, 4 high.
Because that's in-
Okay, and
Since it's
4 by
6.
6. So again, it's the middle. And you know how to do right and left room on sides of the table as well.
Wouldn't,
You're all in the same space in your brain, and you just have to adapt that to left, right, midpoint, or trapezoidal.
0.6, wouldn't it be where 3 is T, when you point this, or you,
What?
on the graph, wouldn't it be at the point T, where 0 to 6? The midpoint?
Doesn't matter if the point's not the midpoint.
Oh, because these aren't evenly spaced?
Yeah.
But it's not always gonna be the exact number.
Yeah, if I give you a function, you would pick the middle values, but in the table, like literally just go to the middle. 12, 12, and, is that correct?
I think so.
Yes.
Yeah, it is.
All right,
So that would be the area of the curve?
yes, approximately.
That's way
It's
easy.
gonna be pretty close.
Which is like the most accurate out of all three?
We'll talk about approximation, or underestimates and overestimates tomorrow. Deal?
Yes.
So, I'd say focus on one thing at a time. I like it, it's a great question, I'm glad you guys are asking for this, because you're thinking, but let's tackle this. Tomorrow we'll talk about how to determine over or underestimates. Okay, so I gave you a strict math problem, but this can be a contextual problem, okay? This can be a velocity function. Because I labeled it V of t, right? Okay.
So wait.
So let's say that's the velocity at time t of a particle. Okay. Particle motion problems are very common, very popular calculus problems, very physics-based. What does the answer, okay, one of your questions might be, what is the meaning of the integral from 0 to 13 v of t dt in context of the problem? So if I give you velocity information, what is the output of that calculation? What does it mean?
Total moving travel.
Yeah. We will talk about the difference between what's called displacement and distance traveled. Okay. Since these are all positive, we do have a distance traveled. Okay. Because, so think this through. We know the relationship. I'm in velocity, antiderivative or integral gets me to a position change, right? So that's my distance traveled. So
Does this only apply
so
to?
here's your proper answer format. You have to address the subject, okay,
That is?
is the distance traveled or you could say the distance the particle traveled. Okay. This is kind of clunky writing. The distance traveled of the particle. Okay, so meaning, right? So it's the distance traveled of the particle from t equals 0 to 13. Okay, because you have to interpret.
So what, that'd be your answer on the test?
That would be a very scripted answer. Doesn't have to be that, but it has to have the elements. It has to have. Basically, what you're doing is you're interpreting this whole thing. You have the time intervals. You have what this means, distance traveled. Okay, and you put that in there just to make clear what you're stating.
How come 48 never shows up in that right now?
Doesn't have to.
So,
It just says interpret the meaning. Doesn't say write the answer down. Right? But you could say the distance the particle travels from 0 to 13 is 48. And you'd probably say, sometimes we'll include this in meters per second.
so what
For
meters?
velocity would be meters per second. So you say in meters here. All right, this is velocity, meters per second, position change, just meters. Okay. What?
Well, they ever dip below the x-axis? and give you
Yes.
measurements?
And that's when this would be displacement, because the particle would actually travel and then go back towards, like, it's like driving from Glenwood to Parachute to Rifle, right?
That'd be stupid.
Your displacement was here to Rifle, but your distance traveled was Glenwood back. So they're different numbers. So if this is not positive, we have to differentiate between the two.
And that's just the rectangle underneath the x-axis.
It's still, it just gives you negatives, right? Because you have negative heights. Okay. All right. Let's quickly look at,
Is the graph of the, so that graph, when it's graphed, that's the velocity function?
yeah, the area under the curve gives you the distance traveled in that case. Yeah, like I said, the connections here are pretty neat.
So does that only apply to like, if it's curved, if it's linear, does this not work?
No, it still works. Like, the concept applies to any function that you could have that's a velocity function. Logs, exponentials, linear, quadratic, whatever. Yeah, so get that concept nailed down in your heads. Okay, really quick. Just so we're clear on what a graph would look like. Okay, the rectangles for a midpoint sum cross at the middle point. So in this case, it would be 1/2 and 3/2. Okay, so the graph is not scale. How wide is this rectangle? 1 unit still, and how high is it? 1/2 squared, right?
Yeah.
So 1/4. That's 1/4. And then this is also 1 wide. How tall is it? 3/2 squared. 9/4. Okay, so tables don't have to be exact in the middle. If you are given a function that and a graph or a graph, you're calculating the exact middle value. Questions? I think you can handle some practice problems.
Yes.
One of the things I saw in the survey was that the practice problems are always harder. The practice problems are pretty much exactly like what I've shown you today. Trapezoid and midpoint sums. Okay? I say pretty much because there might be a small one problem that I don't like that out with. Okay, so at this point tomorrow, we will look at trapezoidal and midpoint sums. So those two sheets that are posted, trapezoid and midpoint. Okay? Yeah, whatever ones say trapezoid and midpoint. It should be listed in Google Classroom in numeric format, like 1C and D and 2C and D. I did.
Oh, you did the
You came, yeah, I just realized. If somebody does.
Emily Collins, William Carter, Jason Gray,